So I just want to start with a recall. We're going to do some practice problems that we didn't quite finish from last time. And I think it's important to compare and contrast some ideas from what we've done before to what we're doing today. So for the recall, we're talking about compound interest. Now, compound interest is when you have interest building off of interest. All right, so it's compounding in the idea that the interest can build on the interest. So that's going to be an important distinction we'll talk about later on. Now, there's two ways it can happen. We can talk about discrete, which says, well, we'll compute the new amount every so often. So maybe once a year, once a month, once a day, it's however often we want to do it. So we're breaking it up into m time periods over the course of the year. So we measure everything in years. T is number of years. R is your interest rate. Remember to convert from decimal to percentage. You do that by moving the decimal place 2 positions, depending upon whether you want to go from a percent to a decimal or decimal to percent. Continuously compounded means it's always being compounded. And in some sense, you can think of, there's a very fancy word, limit, but imagine you just let m get very big. If you let m get very big, then the discrete becomes the continuous. Now, that was from a few lectures back. Last time, we talked about logarithms. And logarithms are this wonderful tool. You can do a lot with logarithms. But one of our big things that we can do, that we want to be able to do, is to say, one thing that it's useful for is bringing terms out of the exponent. So maybe we're trying to find a value that's currently upstairs. It's up in that exponent. And we're just like, come on, how do we get it out? Well, we use logarithms to do it. And logarithms are the inverse of exponential functions. And so what you're doing is you're essentially undoing the exponential part. So if we were in the continuous setting, we can just say if A equals P e to the Q, and we said, well, how can we find Q? Well, take the log of both sides. So if you need to bring something out of the exponent, that's going to be your go-to technique. One word of warning, logarithms do not get along well with addition. So if there's any addition involved, isolate the part with the exponent first and then take the log. Anyways, moral of the story, take the log of both sides. Use the property of logs, you can break things apart. And here, I use the natural log, thinking of it as continuous. We can use log of any base, but we can also just stick with natural log. And now we can use log of e to the q as q, and that lets us solve for q. Okay. So, let's try this out. How many years to 2 decimal places, so it may not be a whole number, how many years to 2 decimal places will it take an investment of $35,000 to grow to $50,000 if it is invested at 4.75% compounded continuously? And I think I missed an apostrophe. All right, there we go. All right, now, looking at this, we see a word. Well, we see many words, but compounded continuously. That continuous part says, oh, that's that E expression. So we have this basic formula, and I'll rewrite it. A equals P e to the RT. And just as a quick callback, when we talk about P, we can think of that, that's your initial amount, how much you put in. Or sometimes you might call it the present value. what is it worth today? And A is, that's in some sense the final amount or the future value. So we have an investment of $35,000. Is that the initial or the future? It's the initial. So there's $35,000 goes in for the P. We want it to grow to $50,000, so that's the future. So that's the A. And now we have the E, that's always there. R, well, we're not going to use 4.75% because we don't use percent. We're going to move the decimal over 2 places. So 0.0475, this is our R, so 0.0475, and then T. So we did problems before that are very similar to this, but previously we said, oh, how much should we invest now to get an amount later? So the difference between now and what we did before is, what are we trying to solve for? And in our case, we're trying to solve for something upstairs, which we couldn't do that before we talked about logarithms. All right. Now you can start by taking the log of both sides, or alternatively, you can just say, well, let's isolate the E. So E 0.0475t is equal to 50,000 over 35,000. So I can move the 35,000 across by dividing. And zeros are fun to cancel, so we can just go ahead and cancel a whole bunch of zeros. And so you get to 50 over 35. And not that we have to do this, but might as well go one more step. 50 over 35, do they have anything in common? They have a 5. So you can factor out a 5 and cancel. You get 10/7. All right, now, how do we proceed? Well, we need to get the t out of the exponent. When you need to get t out of the exponent, what's your tool? Log! Yes! And here, we already have an e, perfect. So log of e to 0.0475t is equal to log of 10 over 7. Now, log of e to something, well, that's the something, 0.0475t. Log of 10 over 7, well, that's when we pull out our calculator and try to remember how to use things. So there's going to be a button for log. There's 2 buttons for log. There's usually an ln button and an log button. ln is natural log, log base e. log stands for common log, log base 10. So I'll do log of 10 divided by 7. And that says, well, this is 0.35667. We don't need to go too many decimal places. We only need to get 2 decimal places in the end, so if you just add a few more decimal places in the computation, that's good enough. All right, are we done? And if not, what do we need to do? Have we solved for t yet? No. But what do we need to do to solve for t? We're close. Oh, so close. We need to somehow move this 0.0475 across. So that's division, yes. So 0.35667 divided by 0.0475, and let's see if we can do that. Divide 0.0475 equals 7.51, because it says round to 2 digits, and it says 7.508, so if we round to 2, just barely over 7.5 years. And that sounds about right. I will say, I did look at some people's exams, and I'd look at answers, and they'd type in numbers like 250,000 for something that should have been about 10. You should not pass by and just blindly put in a number. You should always think, is this a reasonable answer? It'll be surprising how often just that asking that question, is this reasonable, can help you avoid some heartache. All right, do you want to see another one of these, or should we go on to today? Are you good with this idea, or do we want more practice? Well, we'll go on to today then. And if we have time, we can always come back. So, first a thought. It's dangerous to go alone. This comes from a game called Legend of Zelda. This dates back to one of the earliest Legend of Zelda games. And I like this just because it reminds me that, math is a very human activity. And as such, it's best to do it with other people. And so I encourage you, as much as you can, find people to study with, bounce ideas off of each other, look through each other's works and find mistakes. It's really hard to find your own mistakes, but it's not hard to find others. And so if you work together, you can help each other out. So I encourage you, as much as you're comfortable and able, work together, learn together. All right, so what's our goal for today? We're going to talk about simple interest. Now, there's a difference between compound interest and simple interest. Compound interest, we talked about, you're building interest on the interest. Simple interest says, nope, we're not going to do that. Another way to think of it, and I like the way that it's phrased inside the book. It says, well, think of it as like a fee. It's a fee that you're going to either pay to borrow money, or someone's going to pay you for lending money. And so it's, why is it simple? Well, we don't have to keep compounding it, like it's a one time. And okay, so what's the formula? Well, the interest that's going to be paid is based on the amount that you have borrowed or that you lent. So that P is the principal or present value times the interest rate times the time. So we think of the rate as being per year, and time is number of years. Of course, we can do fractions of years as well. There's a second formula, which is that if you take the P times 1 plus RT, well, what is that? That's really P plus I. It's the present value, how much you start with, plus the interest. And so we think of that as the amount. That's why we use A. That's your future value. So if you borrowed money, you'd have to, at the end, pay back the money plus the interest. So that's the P money that you borrowed plus the interest that you have to pay. So that's that formula. So that's the goal for today. And that's the theory. Everything from here on out are examples. So it's pretty quick. That's the idea, but now we need to do some examples. Any questions before we get into examples? You might ask, how do we know if it's simple interest or if it's compounded interest? Today we'll assume it's simple interest, but generally speaking, it will be very specific and say simple interest or compound interest. Okay. Well, let's try these out. So we'll start with the one on the left. What would be the amount due on a $900 loan, which has an interest rate of 6.25%? And again, always assume that the interest rate means per year. 6.25% if paid after 16 months. Okay, So we have to pay back the amount due. So that includes both the amount you borrowed plus the interest. So we can think of that. We can go back and we have a formula, right? You can either think of it as P times 1 plus I RT or just P plus I. Maybe P plus I, let's start with that. So P plus I, which is P plus PRT. Now let's just figure it out. We have a bunch of letters, some alphabet soup here. What is it we want to solve for? Which one of these letters are we solving for? The A, the P, the R, or the T? You can just start guessing. You have a 1 in 4 chance. You'll get it right by at least the 4th time. The A! Yes! You didn't even need 4. Right out of the bat. It's the amount that's going to be due. It's what you have to pay back. It's the future money. Okay, so we're solving for A. That means we must have all the other information given to us. So let's start with the P. What is P based on this problem? 900. The present money. That's the money you borrowed. What you borrowed right now. Okay, so we have the 900. How about R? Do we know R? Yeah, that's given there. So 0.0625, right? Convert it into digits. Do we know T? What is T? 16 months. Okay, so we need to convert 16 months into some equivalent number of years. So how can we do that? Yeah, okay, so there's a great suggestion. There's 12 months in a year, so if you just take 16 over 12, that's how many years there are in 16 months. And so now what do? Well, we pull out a calculator and we just start typing stuff in. So we have 900 plus 900 times 0.0625 times 16 divided by 12, and we get, a nice number, $975. Does that sound like a reasonable amount to pay back for a $900 loan after about a year? Yeah, it's all right. It's reasonable. If it had been like $10,000, would we have say, yeah, that's fine? No, of course not. Okay, so not so bad. I like this simple stuff. It's good. All right, let's do the right example. A loan for $700 was repaid after 200 days, and now there's a note here. What do we mean by days? Well, we're going to use banker days. And this, I'm taking this from the textbook. Bankers have a different measure of time. They get lots of holidays, apparently. So for them, there's not 365 days in a year, there's 360 days in a year. 360 is a much more convenient number. Lots of things divide into 360. Okay, so anyways, 200 days. All right, so a loan for $700 was repaid after 200 days for $745. What was the interest rate of the loan? All right, so we have our same basic formula, right? So I'll write it down again. A, P plus PRT. What are we solving for? And how do we know? The rate. How do we know we're solving for the rate? Yeah, because it told us to solve for the rate. It doesn't have to be subtle. Okay, so that means we better know all these other things. Okay, so let's go through and figure out what all these other pieces are. Do we know what A is? 745. That's the amount you repay. That's the future amount. So that's 745. How about P? Do we know that? 700. That's the amount we borrowed. That's from today. 700. 700. All right, how about T? What will that be? Yeah, it's going to be 200 over 360 because we're going to think of a year as having 360 days. So 200 over 360. Now, if we wanted to, we could probably simplify this. These are both divisible by 40. So the top is 5 times 40. The bottom is 9 times 40. So we can think of this as 5/9. If we didn't see that, the calculator would see it for us. All right, so what do we need to start doing? Well, we need to get R by itself. A lot of algebra is basically the goal of saying, how do you isolate a piece of your expression? So you think about, well, what are some manipulations we can do? So how do we start getting R by itself? So I'll rewrite it. So we have 745 equals 700 plus 700 times 5/9 times R. So how do we get this R by itself? Okay, so let's subtract first. Now this computation I can do without a calculator. 745 minus 700, also known as 45. Okay, so 45 equals 700 times 5/9 times R. Now what? Yeah, we can divide by what's in front. So subtract, then divide. Okay, so that gets us to R is equal to 45 over 700 times 5 over 9. And at this point, we can just turn to our trusty calculator. Calculator, we trust you. You'll never lead us astray, right? Well, as long as we are very careful. So I'm going to be very careful with my parentheses game here. So I'm going to put some 45 divided by parentheses 700 times 5 divided by 9. Now, why do I want to be so careful with parentheses? Well, if you don't put your parentheses in the right place, it might say, oh, you just want 45 over 700, and then you want to times that by 5/9. So be careful. Be careful. And this gives us 0.1157. Well, let's just do it to 2 decimal places. Okay, so that's our rate. If we wanted to write this as the percentage, what would we do? Yeah, you're essentially moving the decimal place. So, or an 11.57% interest rate. Does that seem reasonable? It's not bad. It's a lot better than most credit cards. So yeah. Okay. Well, now that we got our warm-ups out of the way, let's kick it up a notch. You sell your old car to a friend. You accept a 255-day note for $4,000 at 10% interest as payment. Okay, so what's a note? A note says, I promise to pay you. I don't have the money now, but I'll have the money then. So it's an IOU. That's what a note is. So in 255 days, they're going to pay you. And they're paying you the money they borrowed plus interest. All right. But what happens? Well, it turns out you need money faster than 250 days. So after 100 days, you sell the note to a third party for $4,100. So in other words, somebody owes you, and you turn around and you sell that debt to another person. So now that person is going to get the money at the end of the 250 days. Okay. So the question, what interest rate does the third party get on their investment? All right. So let's see what we can figure out. Now you might say, wait, aren't they getting 10% interest? Oh, hold on. Let's see. So how can we figure out the interest rate? Well, we can toss out our formula, right? A equals P plus PRT. What do we know? So we're after the third party. How much did the third party invest? $4,100. That was their investment. So that is, they said, okay, here's the money I'm paying you today. That was their present value. So their initial investment, 4100, goes where the P goes. What else can we say about this? Well, we're trying to solve for R, because the problem says what interest rate. So we should not try to figure out R from the problem. We should try to figure out T and A. So which one do you want to do? T or A? We're going to do them both. T. So how much time will the third party have to wait? So be careful. It's a 250-day note, but they bought it after 100 days. So how much time until they get the money? 150. Because it's not like the time resets. Because the person who's paying back the money pays it back at the end of 250 days. Who they pay the money to, it doesn't matter. It's still going to be at the end of their 250 days. So the time, we can think of this as 250 subtract 100, or 150. All right, so we know how much they invested. They bought the IOU for $4,100. That's their present value. We know how long until they get the money back. How much money will they get? How do we figure out A? Well, to do that, let's just work through and say, how much money does the friend pay? So we'll do a sidetrack here. So the sidetrack for our friend, P plus PRT. So the friend, they put in $4,000. That was their present value. The interest rate was 10%. So that would be 0.1. And the time was 250. So 250 over 360. So I'm putting in our basic formula. That's how much money they're going to pay back. Well, okay. This sounds like a job for a calculator. So, spoiler alert, probably time to break out your calculators at some point if you haven't been using them, but I'm sure everybody loves a good calculator. All right, so that can't be right. I obviously entered that in wrong. There's no way it's 8,000. Let's try that again. 4,000 plus 4,000 times 0.1 times 250 divide 360 equals, there we go. All right. 4,277.78 cents. You can't pay back a fraction of a penny. All right, so that's going to go up here. 4,277.78. All right, so what do you do? We'll write down what we have. $4,277.78. That's how much the person who borrowed is going to pay back. The third-party person paid $4,100, and their interest that they're going to get is $4,100 times R times 150. So we can subtract $4,100 from both sides. All right. We'll go ahead, we can just keep doing this, $4,100. That gives us $177.78. And that's equal to 4,100 times R times 150. And I'm going to $177.78 divide by, throw in some parentheses, 4,100 times 150. That does not look right. Ah! I forgot my 360. Ah! Thank you. That interest rate is way too low. See, that's how you know. You know, if it doesn't feel right, you catch your mistakes. Now, unfortunately for you, you don't get to do the exam in front of a live studio audience. Okay, divide by, parenthesis, 4,100 times 150 divide by 360. There you go. Thank you. Thank you. Okay, so we get that R is 0.10406. Okay. Or 10.4, if we round it to two digits, 10.41%. So the third party got a little bit better than 10%. All right, any questions on that one? You doing all right? Cool, cool, cool. Well, let's try another problem. Wow, so many problems. Well, I should note, if I don't think I said it explicitly before, we're starting chapter 3, which is a different chapter. Chapter 2 was about sort of more theory, more math. It's about functions, and we talked about basics of functions, polynomials, exponentials, and logarithms. This chapter is financial math. So there's going to be a lot of word problems. So we're going to get good at word problems. Well, I hope we get good at word problems. All right. The next one is about buying stock. A brokerage firm charges commission based on the transaction amount. So a brokerage firm is the one who handles the buying and selling of stocks. You say, I want to buy these stocks. And they'll say, okay, we'll take care of it for you. Because you can't just go down to Wall Street and just walk in and say, give me stock. You know, you have to have somebody who can do it. Now, they charge commission. They say, well, there's a fee attached to it. And it's based upon how much money the transaction involves. So a low transaction, there's a small fee, but a bigger percent of the amount. So if it's from 0 up to $2,499, it's a $29 base fee plus 1.6% of whatever the transaction was. Between $2,500 and $9,999, it's a $49 fee but it's only 0.8% of the amount of the transaction. And if it's above 10,000, it's a $99 fee, but 0.2% of the amount. All right. It says find the simple interest rate R earned if 500 shares purchased at $17.64 per share is sold 8 months later at $22.36 per share. Okay. Cool. Well, so we have to solve for R. Well, that's good. We're getting pretty good at solving for R. So we have our basic A. We have P plus P RT. We know what we're solving for. It even told us R. So we don't have to hum and haw about that. We're after our interest rate. You can think of that. How well did we do? Did we beat inflation? Did we do really well? Can we buy eggs this week? We got to find out. Okay, some of these things are going to be quick. T. What will T be? Eight months. So 8 over 12. And if you want, you can see that these are both multiples of 4. So this is 2 over 3. So, all right, now we have to think about A and P. So, which one do you want to do first? The present or the future? All right, let's start with the present. So the present, we want to invest. So, what is P? We're going to make some notes here. P, well, we have 500 shares. They're each $17.64. So take 500 times 17.64. Let's see what that turns out to be. 500 times 17.64. 500, I can type 17.64 equals $8,820. Okay, so that is how much we're paying for the stock. Is that P? And why not? Spoiler alert, it's not P. What have we forgot to account for? Or what have we not accounted for yet? The fees. Because that is something we have to pay. That's part of our investment. All right, so which range are we in? Low, medium, high? Medium. So we're in the medium range. So you say, okay, we need to take 0.8% of this amount. So to get 0.8%, that's times it by point, all right, I have to 0.008. Okay, that's $70.56. That's 0.8%. Add 49. That says there's an additional $119.56. This is from the commission. So our actual investment, when we add the two together, is $8,939.56. So that's the present. That's how much we're putting in. Okay. Now, how much are we getting out? How do we compute that? We still have 500 shares, but now what's the price? $22.36. Okay, so 500 times 22.36 says this is $11,180. Nice! Is that A? And why not? Yeah, we got to pay the commission. Okay. Now, are we in the low, medium, or high range? High. We've moved up in the world. We're going to have the fancy ramen. Okay. So, now we have to pay 0.2% of the amount, so we're going to times this by 0.00. I have to think how many O's do I need. Okay, I'm getting old. 0.002. Okay, so $22.36, that's the 0.2% plus 99, says that we have a commission of $121.36 to pay. Okay, so that's the commission. Now, question, add or subtract? Do we add the commission or do we subtract the commission? The question, who's getting the commission? Do we get it or does somebody else get it? Somebody else gets it. The brokerage. We have to pay this to get our money out. It's a subtract. So we aren't getting the $11,180. We're getting the $11,180 minus the commission. So we take 11,180, subtract 121.36, and that means that our future value is $11,058.64. Okay, so we have our pieces. We're ready to go. So we'll just go through this. 11,058.64 is equal to 8939.56 plus 8939.56 times R times 2/3. And do we need to finish it up from here? We should finish it up. Okay, we should do that. Minus 8939.56. Okay, so we get 2119.08 equals 8939.56. 56, I know how to write that, times 2/3 times R. So we're going to divide that by 8939.56 times 2/3, and we get, we did well, 35.56%. It's pretty good. Well, it's not too surprising if you look at the shares. They went up almost $5 in less than a year. It's a pretty good jump. Forget the fancy ramen. We're going to eat deluxe ramen. I don't know. Well, good investor. Okay. Any questions before we jump into our last one and see how far we can get? All right, last one. If nothing else, we'll finish reading it by the end of the lecture. So a credit card has an annual interest rate of 18.99%. Interest is charged on the average daily balance. They do this once per month. So a billing cycle is 30 days. So I can just sort of read ahead. So there's a 30-day billing cycle. At the start of the billing cycle, there's a balance of $1,924.35. On day 11, there's a purchase of $421.20. On day 21, a purchase of $213.11. And on day 5, a payment of $1,000 is credited. And the question, what will be the interest at the end of the 30-day billing cycle? So, we have day 1, we have day 30. Now, when do things change? Well, there's 3 events that happen. Someone does not use this card very often. Day 5, day 11, day 21. So we'll mark day 5, day 11, day 21. Now what I want to know is what is happening to your balance on these days. On day 1, how much is there? At the start, you have the balance from last time. So that's $1,924.35. And that's actually going to be true from day 1 up to day 4. Because nothing's happening on those 4 days. On day 5, what happens? We made a payment on our bill, our credit card bill. What's the new total? $1,924.35 subtract the payment you made, which is $924.35. That's going to be true up through day 10. Day 11 comes. What happens? A purchase. So we're now going to take $924.35. This is our running total, and we're going to add $421.20, which is going to be a number. Beep, 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 which is going to be 1345.55. Okay, all right. So, okay. And that's going to be true up through day 20. Because nothing else happens. And then day 21 comes. What happens then? Another purchase. 1345.55 plus 213.11, which, okay, we come in, bump, 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 bump. That's 1558.66. And that's true all the way through day 30. Yes? Now, why are we doing all this? What is it we need to do to figure out our interest? We need to figure out the average daily balance. So I need to know how much there is each day, then take the average. From 1 to 4, how many days are there from 1 to 4? There's 4 days. 5 to 10, how many days are there? 6. You can use your fingers 5, 6, 7, 8, 9, 10. 11 to 20, how many days? 10. 21 to 30, how many days? 10. Now, what's your average balance? Well, you're going to take 4 times 1924.35 plus 6 times 924.35 plus 10 times 1345.55, whoops, ran out of space, plus 10 times 1558.66, all of that divided by 30. That's how you do your average. Now, technically we're out of time. Do you want me to finish this, or should we just leave you in the, oh my gosh, we'll never know? I'll finish it. Feel free to head out if you need. Okay, so clear the calculator here. 4 times 1924.35 plus 6 times 924.35 plus 10 times 1345.55 plus 10 times 1558.66 equals syntax error. Okay. This is when you should learn how to use your calculator. Well, all right, type this in again, and hopefully you don't make a syntax error. This is the non-glamorous part of being an accountant. You know, you often think of accountants as living, you know, the high life, going out and just having numbers all the time. Now, that says the numerator is 42285.6, but I have to divide by 30 to get the average daily balance. And it says the average daily balance is 1409.52. You should just ask, is that reasonable? Yeah, it's kind of in the middle-ish, right? Your high is 1924, your low is 924. Middle-ish is about right. Now, your interest, you have PRT. T is 1 month, 30 days, 1/12. R is given as 18.99, so that's 0.1899, and P is that number. So if you take what we just computed, times it by 0.1899, and then times it by 1 divided by 12, we get our interest payment is $22.31.